Okay, let's get started with some basic concepts we're going to be using in the course and some ideas you can hopefully keep in mind. Just an introduction to what this is all about. So, first of all, a mathematical model is what we're mostly going to be studying in any math class, most any math class. It's a simplified description of reality that helps us understand a system or process. So it's a model in the sense of like a model train, like a simple version of a real thing, as opposed to like a fashion model or something like that. So for example, if you're going to build a building and you want to show everybody what it's going to be like and help people understand what this building is like, you'd make an architectural model like this. So this is a model of the Walt Disney Concert Hall in Los Angeles. And of course, it's a lot cheaper and easier to make this. It's a lot simpler than it is to actually build the real Walt Disney Concert Hall. So you build a model first to help understand things. And just like that in math, we're going to describe a real life thing in a way that's much simpler than actually building it in real life. And that's what algebra is all about, hopefully. And so we're going to look at different ways of representing models. So you could describe this this thing in real life in simpler terms with words. So for example, you could say in words, I started 300 miles from my house and drove towards home at 60 miles per hour. Now, that's not precisely what happens in real life, because in real life you don't go exactly 60 miles per hour the whole time. You get some traffic which slows you down. Sometimes you can speed up and go 80 maybe, but maybe this is a simplified description of how fast you went, and it probably works well enough. So that's words. You could also make a table of values. This is a really important one, where you take variables. In this case, t stands for the time elapsed. D is the distance from home. And then you get, so for example, when you've been driving for 0 hours right when you start, then your distance from home is 300 miles. And those numbers go together. When you've been driving for 4 hours, your distance from home is going to be only 60 miles. And then it takes 5 hours for your distance from home to be 0. So this describes the situation with your drive home pretty well too. And sometimes a table is easier to use than other things. You might be able to make the table, for example, before you're able to make an equation, before you're able to make a graph. So we're going to focus on tables because they're a good way to help understand the relationship between the variables t and d here. You could also have a graph over here. Let me scroll, whoops, so you can see the graph there. Sneak preview of the equation. So the graph shows you these points on an xy plane, or in this case, instead of x, it's t, and instead of y, we have d for time and distance, but you could call it x and y if you want to. So yeah, all of these points, like the 0, 300, when t is 0 and d is 300, that should be showing up here. Whoops. So that point is right there. And then after you've driven 1 mile, you have that point 1, 240. That's going to show up about right here on the graph. And the other point, 2 and 180, is going to be right there. So it's describing the same thing with just a different way of looking at it. Sometimes the graph shows you the information you need. Sometimes it's easier to think with a table. We're going to need to be fluent in both, and how to go from a table to a graph, how to go from a graph to a table, and of course how to go from a description in words to all of these things. There's also the way that you're probably most used to from algebra classes is an equation like this, where you just write down a sentence which describes the relationship between D and T. And this is the kind of equation and the kind of mathematical model we're going to be looking at in Chapter 1. It's an example of a linear model. And you've studied them before in beginning algebra, so we're going to move through it a little bit faster. And as we go forward, I'd like to keep emphasizing that we're not just studying the models themselves, we're studying the ways of describing them. Because in the real world, you don't know which one of these kinds of descriptions you're going to get when some math comes up in your life. Probably what you're going to get is a description in words. And if you want to do anything with that description in words, it will really help to have an equation. So how do you go from the description to get an equation? How do you go from the description in words to get a table of values? What is the graph going to look like? How do you go from a graph to an equation? All of these things are what this class sort of focuses on. So let's keep that in mind as we go forward.